Hello, everyone. Welcome to the second workshop of the AI video hackathon. Today, we are going to have a workshop from SwarmZero from Thomason. As always, any questions, any queries, please just put them on the Discord channel. Thomason's got a really exciting workshop for you all, so I hope you're excited and ready.
All right, great. Welcome everyone, and thank you very much to the Livepeer and Encode team for having me here today. I'm the founder and CEO of SwarmZero AI, and essentially what we're building is what we call the App Store for AI agents. So before we get into today's workshop, we're going to go over a certain amount of content about what we do and also what decentralized AI is. And a lot of this would actually help you with understanding how to complete our bounty and to actually build AI agents. So we're just going to look over the overview of the project. We'll have a look at some demos, talk about decentralized AI, and if there is time, we may do some hands-on coding. Otherwise, we'll just go through the code because there is a lot in there. And of course, we'll talk about the bounty, and I'll share our contact details, how you can reach us. So very quickly today, many of you in the audience are interested in building AI agents. You're interested in using AI to automate processes, and you figured out you could probably sell your agents to others. Well, the reality is that while you're developers, there's a lot of skill sets that we don't naturally have to be able to actually take these agents to market, sell them, find the exact customers, come up with your branding and all that. And that actually makes it very difficult for you to sell whichever agent you've built. You essentially have to create your own startup, which is the path I took last year. So for the customers, the people who would actually use your agents, they're looking for agents that can help them automate their processes. So what they end up doing is searching all around. They end up with analysis paralysis, and they either spend money on Fiverr for low quality agents, or they go to large tech companies, large consulting companies like Accenture, who just reported recently that they've made billions of dollars. So people are paying premium prices for AI agents on built by consulting companies. And anybody could be a customer of an agent. It could be a marketer, a VC analyst, a software engineer, pretty much anyone. So our solution is to help you as the developer access these customers. So we've built what we call the App Store for AI agents, which is basically a marketplace where both the builders of agents and the users can actually meet each other. So for you, the builder, we'll give you the workflow builder as well as the SDKs. So you'd see our SDK in action today. And of course, this actually comes with payments integrated. So you don't have to worry too much about how to actually get paid for the work you've done. And of course, for the customers, we'll let them search through the entire list of agents and actually pick the best agents for the job. If they're not satisfied with the agents they see, they can actually create a bounty and set a price or a reward, a bounty reward, which basically describes what they would like done. And essentially, any of the agents on the platform can compete in this bounty. So this means there are multiple opportunities for agent builders like yourselves to actually create revenue. So here's the team. We're all experienced in both AI and Web3. And we just graduated from Outlier Ventures Accelerator. Here are lots of the companies who are working with us. And of course, Livepeer is one of our core partners. So let's quickly talk about the current state of AI. For this presentation, we may not be able to get people's hands raised, but essentially what you realize is there are not as many people who make money from AI services as those who actually contribute to these AI services. And what do I mean by that? Essentially, every day you're producing data, even when you're not using your phone. It's just in your pocket, you're walking, you're producing location data, and all sorts of other information is being gathered about you. And that is being used to train powerful AI models. And these models earn the companies billions of dollars, and that revenue is never shared with you. So what we have is we're heading towards a scenario where most people won't ever be able to profit from artificial intelligence while also not being able to control it, even though they're contributing to it. So the best way to define AI, because there's a lot of different terms out there, the best way to talk about it or to define it is simply simulation of human intelligence by machines. So you can categorize it in three different ways. There's narrow AI, which is just focused on specific tasks, so like Siri or a movie recommendation engine for Netflix. Then there's what we call AGI, artificial general intelligence. So this is basically any AI system that can pretty much do what humans can do. So AI agents are in this realm of AGI. And then we have artificial superintelligence, which is, AI that goes way beyond what humans can do. So what's practical today, of course, is at the top, narrow AI. But we see that with the advancements in AI now, especially with AI agents, many people believe that we are actually on the path to superintelligence. So let's get some terms correct. There's AI, which is the actual field of study. Then machine learning is those set of algorithms that learn from data. So it's a subset of this field called AI. And deep learning is basically those algorithms that mimic neural networks. And then what's popular today is generative AI. So these are the algorithms that create new data instances that can actually mirror properties of trained data. So if you look at ChatGPT using the GPT LLM, large language model, it's not actually thinking, it's really just predicting. And it's really good at predicting because it's ingested so much data. So it's able to generate new content because it's just seen so much. And because it's seen so much and it's really accurate, it appears to be reasoning. But these generative AI models don't reason. So the real killer app, as we all know, was ChatGPT. So it took only 5 days to reach 1 million users, whereas it took a platform like Netflix 3.5 years. Even Facebook was 10 months. And essentially, this tells you how much demand there is to build generative AI products, and specifically AI agents, which you'll be building in this hackathon. So just to understand some terminologies, there's assistants, there's co-pilots, there's agents. So an assistant is pretty much, and of course, all of these use generative AI models. So an assistant is more time consuming. You have to be there, prompt it, keep telling it what to do. A co-pilot is less time consuming and it's a bit more autonomous. So while you're coding, it can be, coding with you. You don't have to prompt every single time. But then there's what is fully autonomous, which is the agents. So an agent can take a prompt and just go ahead, execute everything, and come back with a result for you whenever it's ready. So this is what we enable on our platform. So the best way to define an agent, an AI agent, is that it's a goal-driven program that interacts with an environment, its environment. Then it's able to make decisions using the LLM for planning. And then it can actually take actions, and it can take these actions autonomously. So you don't have to be there to prompt it the entire way. Just give it the goal. You tell it what the tools are. You provide the LLM to use, whether it's GPT-4, the new O1 model, now at 3.2, anything, and then it goes ahead. So, of course, the quality of the model will determine how good it's able to take those actions. So let's look at some quick demos of our platform. Okay, so actually we can skip. Okay, I'll show part of this demo. So here, what we're going to look at is an AI agent that is able to actually help you, help your users figure out whether a transaction is, or an account on a blockchain is safe to interact with or not. So here, what's happening is we're using an agent that has a tool. So this tool is able to interact with some risk model provided by one of our partners. So here you can see you're asking the agent, is it safe to interact with this address? And pretty much what this does is that the agent figures out it needs a tool to get the job done. So it finds the best tool for risk modeling transactions, accounts, and then it goes ahead to use that tool to get the job done. Another agent that we could look at will be the stocks agent. So we're just having my internet is a bit slow today. Okay. So with a stocks agent, you can actually do more things. So remember that agents should have more capabilities than just chatting. So with an assistant, you can just keep chatting all day, but what people want to do is actually take actions. So you can have a more agentic assistant by giving it what we call widgets. So widgets will be available in the SDK soon. But as of today, here's a demo of how once you deploy agents that have widgets, you can actually get them to get your users to interact with the user interface. So if you're building something that generates videos or generates images, you can actually have a widget in there where they could probably preview part of the video, maybe edit it, things like that can actually improve the experience for the users. So more demos will be coming up soon. All right, so what exactly is decentralized AI? It's a term that's been thrown around a lot now, especially within the last 6 to 9 months. So one thing to note, while it may sound controversial, is that AI doesn't need blockchain. And what do I mean by that? You can already use ChatGPT today without signing in transactions. You can already train models without putting them on chain. So where is this need for AI and to actually leverage decentralized technology? If you look at recent things in the news, you see a lot of bias in certain powerful models from organizations. You look at fraudulent models that have been exposed only because they were open source. So you can only imagine what's happening behind the scenes for models that are not open source. You can even see governments around the world now abusing this technology and figuring out ways to train their models with propaganda in the data sets, which of course would mean that they would then restrict anybody else in that country, everybody in that country, to only use their falsified model. Then of course, there's also governance issues. So if you look at recent events in certain AI companies, you see that there are lots of governance issues where the co-founders either depart or are fired. So all of these issues tell you that there's there's too much power that's being put in few central entities, and that power can easily be abused or can be misused by another third party. So blockchain keeps AI accountable and transparent. So as we say in crypto, if it's not your key, it's not your crypto. Now, these days, we can say if it's not your AI, it's not your reality, because this content is now being generated. And if you're not involved in the process, if it was all centralized behind closed doors, you don't know what was fed into this model, you have no way of truly verifying what's in front of you with 100% certainty. So many tech CEOs are talking about decentralizing AI. There's Peter Thiel, Mark Zuckerberg, who's been talking a lot about open sourcing AI, as you can see with their recent Llama 3.2 launch. And of course, there's Imad Mostak, from former CEO of Stability AI, who has actually been really prominent and really visible in a lot of crypto events recently. If you check, if you do some research. So what would this decentralized AI stack look like? So at the base layer, you have the compute layer. So this is essentially where the models are being trained, or they're being hosted, or they're being provided. So platforms like Livepeer exist in this layer. Then there's the knowledge layer. So there needs to be data sets that are used for training the models. So the models and the data sets are in this knowledge layer. Then finally, there's the application layer. So earlier we spoke about the assistants, the co-pilots, and the agents. So SwarmZero focuses on the agents aspect, which are able to interact with the models that are running on this GPU networks. So of course, the enabling technologies are blockchain, consensus protocols, consensus algorithms, verifiable computation, private data computation, of course, because you don't want to send all your data to OpenAI, through ChatGPT, computes in the form of GPUs. And none of this, I'm not trying to paint a perfect picture. There are a lot of challenges and considerations. So the scalability issues, there are the smart contract risks that we're very well aware of in this space. There's the costly verifications, and of course, data quality and authenticity is a major challenge, because you have to be sure that the data coming in is from a valid source and is actually very useful. Just a little bit of bad data can really throw off the model. And of course, there's the hardware risks and even regulatory risks. So what is SwarmZero? At a high level, we think of ourselves as a peer-to-peer network for artificial intelligence services. But the way we market ourselves today is that we are that app store for AI agents. And we've already explained what an AI agent can do. So in our platform, we allow you to not just build agents, but to also build swarms of agents. So a swarm of agents essentially can act as a team. So we'll be seeing how that team of agents today can actually go ahead and even publish, generate videos using Livepeer. So at a high level, here's our architecture. Our agents exist in a peer-to-peer network. They can interact with each other, and they can actually call anything. So when you create an agent with our SDK, you could actually run it locally, or you could deploy it to the network. So when you run it locally, it's completely isolated. So you can have your private agents, and you can even host your own open source LLM. So if you were to use Llama 3 or Gemma, or any of the open source large language models, our agents are actually able to connect to them. We integrate with over 20 different models as of today. So our agents can talk to blockchains, they can talk to other agents, they can talk to models, they can talk to IoT devices. We've had people run our agents on Raspberry Pis. They can talk to anything in the web, essentially. So if you think that Google can help you find anything over the internet, SwarmZero can help you do anything over the internet, because the agents are able to take action. So here's a quick demo of what that looks like. So if we rewind this, here's an older version of the platform. So we called that the Agent Hub. So you can see multiple AI agents on the platform, on the App Store. It could be crypto, it could be non-crypto. You can do anything you want with a platform. And here we're going to create a new agent. We're doing this with the no-code UI. You could use the SDK. So for the hackathon, you'll be using the SDK. So here what we're doing is we're creating an image generator agent. And we're going to tell it to basically take the user's prompt and then go ahead and generate an image. And you can actually monetize your agent. We're making this one free, but pretty much this is how you would set the price. And your agent is only as good as the models and the functions. So we're adding a function tool here that is from Livepeer, which is the text to image tool. So that's what the agent is going to use. Then when it comes to creating a swarm, what you would do is basically add as many agents as you would like, and then handle the orchestration using the workflow builder. So a more advanced version of the workflow builder will be coming out soon. You hit save, and now your swarm is generated. So let's use that agent that we built using the Livepeer image text to image tool. So we're just going to enter a prompt here, which just says, I would like to make an NFT collection, but I need inspiration for the images. Can you make an image of, and this is just something funny and memey, at a giraffe in a suit. And you can see over there, it's generated that image using the text to image tool from Livepeer. So you will be able to achieve the same thing when you use SwarmZero for your hackathon project. Okay, so you might be wondering why build this if something like the GPT store exists. The problem with the GPT store is you can only use GPT models. You can't use any model you want. You're locked into their platform. And what they have is really more of assistants than agents. You can't really leave these to run operations for a long period of time. If you wanted to generate a large video, a 60 minutes video, you won't be able to do that over here. You'd have to use, basically write your own code to build out the entire thing. Then, of course, today's SDKs, there's Llama Index, there's LangChain, there are many of them, but the problem is they don't help you actually deploy your agents and get it in front of your customer. You're not just building the agents for building sake. You actually want to monetize this agent. So that's where we come in, right? We give you the no-code UI, as you've seen, where you can select different models. You can orchestrate your agents, and then you can even set the price on the agents. So once you deploy the agent, everything is already configured, and whoever is on our platform, all the customers will be able to access those agents. And of course, our SDK we have the SDK as well, so you can actually build more complex agents than just with the UI, if you'd like. And it's actually very lightweight. We will have a token. I can skip through this. We will have a token, but essentially, because this is a decentralized network, you have to incentivize the nodes and the agents. So the agents, people will pay agents to do work. If you create a bounty, agents will get paid when they're participating in the bounty. And of course, developers will have to stake their tokens to ensure that the agents always respond with honest information. So we can skip through this, but very, very briefly, what we're aiming for is essentially what we call this flywheel effect. So you won't just build agents, you'd also be able to, build models, do research, whatever, and feed it all together into one platform. As of today, the focus is just on the agents, and that's all you have to focus on for this hackathon. We're now about to release our public beta. So you're actually one of the first people who would have access to our platform. The SDK has been open source for a while, but the actual agent builder will be public within a few weeks. And testnet launch will be later this year. Mainnet and token launch will be next year. So, okay, let's look at the code. I would say in the interest of time, we will probably just go through the source code, but not actually develop. Okay, so we've spoken about agents. We've spoken about swarms of agents. So the same way you write software is pretty much the same way you're going to end up building these agents or building swarms of agents. The same software design principles matter. So composability is important. You don't write one large function that does 1,000 things. One function, one thing, one class, one thing, one module, one thing. In that same way, that's really how you approach agent development, AI agent development, or swarms of agents. So what we've done here is we actually have 7 agents. There's an orchestrator one. Maybe you can count that to like 8. But this is what the swarm looks like. So when a user sends in a prompt, so a prompt is, what you type into ChatGPT, the instruction or the goal. When you send in the prompt, hey, I would like to generate this kind of video and upload to YouTube. When you do that, that actually goes through a very complex network of these AI agents. So looking here, the first agent is the orchestrator. So this is sort of the brain of the swarm. And you can have as many swarms as you want. We're called SwarmZero because we're the base swarm for all the agents. So all the agents by default are in a swarm. So here, the orchestrator, if you notice, has access to the GPT-4o model. So each agent here is using an LLM. Remember, an agent is able to plan. It receives instructions. It's able to plan, and then it has tools to actually execute the goal. So once you send in a request or a prompt to generate a video, this agent figures out which of the other agents are necessary for the process. Maybe you might just want to generate but not upload, or you only want to generate images because Livepeer provides multiple different AI pipelines. So this agent figures out the full plan of what needs to be done. And it has access to different tools. So it has tools for basically file management. Today we support local file management. Within a couple of weeks, we'll also support cloud file management. So whether it's AWS S3 or even on decentralized platforms for decentralized file storage. So the typical flow is that the prompt goes into, so this agent comes up with the instructions, and now it tells the first agent in the sequence, which is the script writer agent. It tells it to go ahead and write a script for the video. So the reason you have these all broken down is because you want to keep things as modular as possible. So if something fails, at least you know where it's failing and you don't have to restart the entire process. So if you're already good at writing code, or if you understand basic software principles, software design principles and architecture, you can transfer that same mindset over to designing agents. So this first agent, its single responsibility is just to generate the script. So what are we, what's the video going to look like? And for that, it uses a different model. It uses Claude 3.5 Sonnet. So remember, this uses GPT-4o. So our platform, you can actually use as many agents as you want in a swarm, and each agent can have different LLMs that it uses. So this one is using Claude 3.5, same with the next. So it generates a script of the video. It passes it on to the script, the scene writer. So there's another agent that's going to actually generate the scene. So what happens, so if this is the script, what happens in each scene? And now we will need to generate the actual videos. But before we can do that, what Livepeer provides is text to image and image to video. So we will need to merge these into two processes. So the ability to prompt to get the best image will need prompting. So you can prompt agents, but agents can also prompt other agents. So this agent is going to generate the prompts for every scene that the scene writer generates. So if the scene writer generates 10 scenes, for each of those scenes, it's going to write a prompt that will be used to actually generate the images. So each scene now has its own image, and that gets passed on here. Again, it uses Claude 3.5 Sonnet. Now, this is the first agent that we're seeing in the workflow, apart from the orchestrator that uses a tool. So this agent receives all the scenes and then the prompts. So for each one, it then generates an image. But how is it generating an image? It calls Livepeer using the text to image tool that is available to it. So this agent goes ahead to send each of the prompts to Livepeer, and Livepeer returns the images to this agent. Once all the images are compiled, it passes it on to the next agent. So the goal for this agent is to finally generate all the videos. So we have multiple scenes. Now each of those scenes has a prompt. Each prompt leads to a new image. So we're going to use the image to video tool from Livepeer to now generate the videos. So this means we're going to end up with multiple videos. So all the scenes, all the images come in, and then we pass each one to Livepeer, and we get the exact number of videos. So if there were 10 scenes or 15 scenes, we get 10 or 15 videos from Livepeer's AI pipeline. Next is the video editor. So we have all of these videos, these video clips. Each of them usually lasts about 4 seconds. So now we need to snip them together. So now we're going to use GPT-4o. So you can pretty much use whatever you want. We support Mistral, we support Llama 3, we support Gemini, we support so many open source LLMs as well. So here, now we're going to switch back to GPT-4o. And in reality, some LLMs are better than others for specific tasks. So that's also why we switch between LLMs here. So it can actually save you money when you switch the kind of LLM you're using. So here, we're going to use a different tool that we built, which is called the video scene editor. So you can imagine now you have, 5-10 different video clips. So what this agent is going to do, it takes each of these videos and then stitches them together as one final video. Then we go to the video publisher. So the goal of the video publisher is to finally get the video published to YouTube. So for this, we use GPT-4o. In reality, you may not even need, for very simple tasks or straightforward tasks, because this is just uploading the file to YouTube, which of course requires credentials. You don't always have to use a super powerful model. So this is the benefit of having a modular platform like SwarmZero. You can swap out components that you don't want. We could easily have just used GPT-4 in this instance, instead of even, GPT-4o. So now the final video file is passed to this agent, and this agent uploads it to your YouTube channel. So this could be anything. It could be YouTube. It could be, LinkedIn. It could be TikTok. It could be Twitter, Facebook, wherever. So that's essentially how you use a swarm of agents. You coordinate them together, and actually you don't have to do anything. You just type the prompt, and you provide each agent with the tools. So where do these tools come from? Our platform, apart from letting you have, browse through many agents and swarms, will also provide many tools on the platform. So when you're building your agents, you can just keep adding tools in there. If you use the SDK, the tool is pretty much just it's a Python script. So you would generate your own tool, and then your custom tool. Then you pass it into the agent, and I'll show you how that looks like shortly. Okay, so that's at the high level. That's how it works. That's the magic. That's how you're able to take a prompt and end up with a video on YouTube using both SwarmZero and Livepeer. So the documentation can be found on docs.swarmzero.ai. We have an example there. I could probably even share that slide. Yeah, so if you go to docs.swarmzero.ai, you end up here. And if you look at the example section, if you click examples, we have another swarm that's able to generate a full stack dApp. So it gives you, all you do is you enter a prompt, and then at the end of the prompt, it gives you your Solidity file, your React front-end code, your back-end code as well. So the Livepeer swarm, everything I described is all here. So the way it works, you would need, of course, your API keys from OpenAI and Anthropic. If you only have OpenAI, it's fine. In our configurations, you can just change it yourself. Then, of course, you'd need your Livepeer API key. And you need to do some credential setup for your YouTube channel so that the agent is actually able to access your YouTube channel. So all the code is here. You can check it out, all the instructions of how to set up the agent. And as mentioned, this is what those tools look like. So we manually built these tools. So you can see there's tools that are used for saving files, reading files, downloading files. Then the Livepeer tools can all be seen here. So this is how we're actually converting the text to images, then image to videos. There's other things like upscaling images. Livepeer also provides image to image. And I believe, another one is segment anything, even audio to text. So all the pipelines that are provided by Livepeer are available here in this example. And there's all the tools you can go through to pretty much see how everything works. And the upload tool, when you want to publish to YouTube, right? The upload tool is here, and this just goes, to authenticate. It launches a screen in the browser, so you can authenticate the agent to publish the tool. So this is the core, right? We have the tools. So now this is the configuration, the core configuration for the project. So the main swarm agent uses GPT-4o, if you remember, and each of the other agents, as I mentioned, they use Claude 3.5 Sonnet. So what you can see here is how these agents, you basically just provide it in a single TOML file, all the list of agents, and this is the instruction or the goal for the agents. Some agents can have more, you can put more complex, prompts in here. One thing to note is that the more complex the prompt, the more tokens you would use, but of course, the better quality of your output. Then this is how you pass in your tools. So it's a list of objects. The entities in the objects are the model, the module, and then the name. So here we're checking our tools folder, and then we're just taking the text to image. So this is the agent that takes in prompts and generates images for each scene in the video. Here's the other one that generates the videos from the images, and other agents here as well. You can see now we switch back to GPT-4o. So we have a multi-agent system with multi-LLMs you can use, and of course multi-tools. You can use anything you want in there. And here's how the swarm looks like. So you load your configuration and you create a context. So this context is what the swarm uses to share information across the other agents. The swarm itself has its own prompt because you can treat it as an agent. And this is how you can pass in functions. So these are the tools that the swarm itself uses. So the swarm has file management tools for itself. So we have another class called Hive agents. An example of that can be seen in some of our other, demos. So if you look at this one where we built a news, an agent that can read the news. So in the same way, you have Hive agents that can load, a tool for fetching files. So here you can see we have a swarm, and this swarm, you can pass in your agents manually. You can pass in your Hive agent classes in here, or you can just put all of them in the config file, then pass the config file to the context and pass it in here. So that's pretty much, that's even simpler because you don't have to write as much code. You just configure them with that specification file. And once you have it, all you do is just run agents, or in this case, Livepeer swarm.chat. So whenever the users send a prompt, it comes in. So here you can see, so that's what it's going to look like. Once you run the code, you're able to enter the prompt and then, say create a video on whatever, and it goes ahead, it generates the final videos. So as you can see, there's the different images, the different scenes for the images, and then there's the different videos that then get compiled into this final video. So to have a quick look at what the outputs could be, so here's one. You should be able to see the YouTube tab. So here's one we generated previously. Some videos, sometimes could take anywhere from 5 to 10 minutes to run, depending on how complex a video is. So here is a video that was generated with our swarm, which is basically it's a sports car. So as you can see, you can see each scene happening. So this is like one scene, lasts about 4 seconds. Then there's another scene. So it's one prompt. From that prompt, you have a scene or a list of scenes. Each of these scenes have images. Those images get converted to videos. Those videos are stitched together and then finally uploaded to YouTube. Okay, so the bounty, the ideas, right? So for the actual bounty, now you're going to use our SDK, and also you get limited access to the platform. So there are different things you can build. You can try to recreate what we built, but do something even better, maybe a longer video. You could try building a video for 30 minutes. Or if you remember a few years ago, Netflix had this Bandersnatch movie where as you're watching the video, you can select a different path. So you could have agents generate new scenes in the video based on the path that the user selects. You could create different kinds of assistants, anything, whatever you can come up with. But the rules are that you have to build an agent or a swarm of agents, and you deploy them to the platform. And of course, you have to use our SDK. Our SDK is open source and available on GitHub, so everything is in the documentation. And of course, you have to use one of Livepeer's tools, which are provided through which can be seen in that example. And the prizes, so you can win up to $2,000 in prizes, $2,000 in prizes. So the first prize is $1,000, second prize is $500, third prize is $300, and honorable mentions. There'll be two $100 prizes for any other project that's at least made an attempt to create their agents. All right, so that brings us to the end of this presentation. Special thanks to Livepeer and Encode for putting this together. Here's the QR code. You can find anything on there, or other demos, documentation, blogs, even the SDK. Everything is all there. So with that, I'll just give you a few seconds to scan this, but that brings us to the end of the presentation.
Amazing. Thank you so much, Thomason. That was amazing. Thank you. Yeah, I feel like I'm speaking for everyone in the chat who's saying that was really well done, super informative. There were a couple questions in the chat. Robert was asking about if you could give some ideas of SwarmZero utilizing Livepeer's AI services, but I think you've basically done that. Also, if you could potentially send a link to the presentation slides, that would be super useful as well. Josh was saying they need an invite code to use the platform.
Yes. So I'm just sending two links now. One link is for the presentation. The other link is for everything else, about us, the SDK. So what I'll suggest is for people to start with the SDK, and then on the Encode channel or on our Discord, you can message us to get access. So basically, you just have to send in your email and then fill out your form, and of course prove that you're part of the hackathon, and from there we'll give you access. I see a question from Samuel. Can other open source models be used from Hugging Face or other platforms? Only supports predefined models. If I share this, I'll share a page quickly. You could use, so these are the models we support today. Just going to share this specific tab. Okay, so these are the models we support. So pretty much everything that OpenAI has out there. Same with, Anthropic, even as you saw, I use Claude 3.5. So this is even, this list is even not complete. So you can use even more. Mistral has a lot. Now they have the Pixel model. We don't support that one yet. And then these are all open source models. So if you check Olama, anything that's available here on Olama, as long as you're able to run it. So even the Llama 3.2 model that just came out, if you can run this model locally, because it's an open source model, so you have to run it yourself. So if you're able to run this model, all you have to do is just connect it to our platform, and you should be good to go. So for the models on Hugging Face, we don't yet have a direct connection to that, but we could see about a Hugging Face provider. Maybe in some cases you might want to use. I think Hugging Face also provides inference, or they have inference providers for LLM, so we can look into that. But each of these ones, you can just get an API key on their websites, or you can just run, a local. You can just run this open source models locally. Okay, and then for Caleb, for API keys, so Livepeer API keys, OpenAI API keys. For SwarmZero, you don't need an API key, but for Livepeer, you can just request on the Livepeer documentation. So actually, in our docs as well, we showed you how you can go to Livepeer and get an API key. But for OpenAI and the others, we won't be providing API keys. Those you'd have to create an account on OpenAI and then get your own API key. I see a previous message from Razvan. So the white car video was stuttering a bit. Is it according to the scene scenario, or it happened during render? So maybe it could also just be, you know, screen sharing or something. But if you mean when it's switching between scenes, so the video itself, the model used, if I remember, I think it was a stable diffusion model. So that was used for generating the images. I'd have to check what was the exact model used, but there's a whole list of models you can use on there, so you can switch and try anything. But it's switching between scenes, so maybe that might seem choppy because we use the custom video editing tool, Python script, to merge all the videos together. So you could, you could use any of the other, models that Livepeer supports. Okay, someone asked they couldn't scan. Yeah, so that link, so the QR code, I've already sent the link that the QR code takes you to. So that's our link tree. So that's provided there as well in the chat.
I will also send in the Discord channel those two links as well right after this. So those will be accessible. Yeah, anything else from you, Thomason?
No, that's everything. Thank you very much. And I'm really looking forward to seeing what people build. Amazing.
Yes, so are we. So if no one has any other questions, that is all from us today. I'll edit and upload the video and put it up and send it to you guys on Monday. Okay, thank you very much. That is all from us. Okay, bye everyone. Bye.